How can hydrogen gas be exposed to extreme heat or energy to form hydrogen plasma? To convert hydrogen gas, H2, into hydrogen plasma, it must be exposed to extreme heat or energy to strip electrons from hydrogen atoms. Here's how this process works. Step-by-step process to create hydrogen plasma. 1. Understanding plasma formation. Plasma is the fourth state of matter, where atoms are ionized, meaning electrons are stripped away from the nucleus. In the case of hydrogen, this means H2 molecules break into individual H atoms, then become H+ ions, protons, and free electrons. 2. Applying extreme heat or energy. A high-temperature heating, thermal ionization, method. Hydrogen gas is heated to millions of degrees, 10 C using electric arcs, plasma torches, microwave radiation, ECR, electron cyclotron resonance, laser beams, inertial confinement fusion, high-voltage discharge, Tesla coils, Z-pinch. Effect: heat breaks hydrogen molecules into atoms, then ionizes them into plasma. B. Strong electromagnetic fields, magnetic confinement. Method: plasma is confined and heated using strong magnetic fields in tokamaks, ITER, SST1, JET, K-star, etc. Stellarators, Wendelstein 7X. Effect: the plasma remains stable at extreme temperatures for fusion reactions. C. High-energy particle collision, accelerator-based method. Hydrogen gas is ionized by electron beams used in particle accelerators, radio frequency waves, RF heating. Effect: high-energy collisions strip electrons, creating plasma. 3. Controlling and sustaining hydrogen plasma vacuum chambers. Plasma must be maintained in a vacuum to prevent rapid recombination into neutral hydrogen gas. Magnetic confinement. Superconducting magnets control plasma shape and prevent it from touching reactor walls. Electric fields, used to accelerate ions for controlled energy extraction, like in plasma thrusters. Where is hydrogen plasma used? Fusion reactors, tokamak, stellarator, simulating the sun's fusion process. Plasma propulsion, spacecraft engines used in ion thrusters for deep space travel. Plasma arc welding. High-energy hydrogen plasma is used for precision welding. Plasma cutting machines, superheated hydrogen plasma cuts through metals. Medical plasma therapy, used for sterilization and cancer treatment. Hydrogen plasma reactor design and India's nuclear fusion advancements. A hydrogen plasma reactor is a device that heats hydrogen gas to extreme temperatures, turning it into a plasma state where electrons separate from nuclei. This is the key to nuclear fusion, which aims to generate clean and limitless energy. Key components of a hydrogen plasma reactor. Vacuum chamber, a sealed chamber, usually a tokamak or stellarator, that removes air and holds the hydrogen plasma. Magnetic confinement system. Superconducting magnets generate strong magnetic fields to trap the plasma and prevent it from touching the walls. Heating systems. Plasma is heated using radio frequency, RF waves. Electromagnetic waves heat the ions. Neutral beam injection, NBI, high-energy hydrogen atoms collide with plasma to heat it. Ohmic heating, electric current is passed through the plasma. Fuel injection system, uses deuterium, sweat H, and tritium, PH as fuel. Cooling and energy extraction system, converts fusion heat into electricity using a blanket of lithium, which absorbs neutrons and generates heat. India's advancements in Nuclear Fusion Institute for Plasma Research, IPR, Gujarat. India's leading nuclear fusion research center. Houses the SST1 tokamak, a steady-state superconducting tokamak designed for plasma experiments. India's contribution to ITER, International Thermonuclear Experimental Reactor. ITER, based in France, is the world's largest nuclear fusion project. India contributes key components, including cryostat, world's largest vacuum chamber, built by India's L&T. Superconducting magnets, developed by Indian scientists. India will get access to ITER technology, helping it build its own fusion reactor in the future. Aditya L1 mission, studying hydrogen plasma on the sun. Aditya L1, India's first solar observatory, is studying the sun's coronal hydrogen plasma to improve our understanding of fusion. Future of hydrogen plasma and fusion energy in India. India's own fusion power plant, projected 2050 plus. With experience from ITER, India aims to build its first fusion reactor by 2050. Hydrogen plasma for space propulsion. ISRO is developing plasma thrusters for satellites and deep space missions. Future spacecraft could use fusion-based propulsion for interplanetary travel. Plasma-based industry and medicine. Plasma arc welding, used in metal cutting and joining. Plasma medicine, used in sterilization and cancer treatment.